Welcome students, I am Srinivasan, Assistant Professor, Department of Computer Science. In this video, I am going to explain about inter-process communication. How processes are communicating with each other. That's what we are going to learn here. So, there are two types of processes available. One is independent process, another one is cooperating processes. So, an independent process is not affected by the execution of other processes. That is why it is independent, it is not affected by other processes, while cooperating processes is affected by other executing processes. So, though one can think that those processes which are running independently will execute very efficiently, in reality there are many situations when cooperative nature can be utilized for increasing computational speed, convenience and modularity. Inter-process communication is a mechanism that allows a process to communicate with each other and synchronize their actions. The communication between these processes can be seen as a method of cooperation between them. So, we have two processes, one is independent, another one is cooperating processes. Independent processes is executing independently, it is not affecting other process, it is not be affected by other processes, and cooperating processes will affect other process and it can be affected by other processes. So, by executing more than two processes simultaneously, we can increase the computation speed. That is why we prefer cooperating processes. So, there is a cooperating process which execute parallel with each other. So, there will be problem arises. So, that is the problem we are going to see in the process synchronization in next video. So, here we will discuss about how these processes communicate with each other. Processes communicate with each other through shared memory and message passing. There are two methods, one is shared memory and message passing. Here in shared memory, memory which is primary memory which is shared among more than one processes. So, those processes which have access to that shared memory can access the memory which is shared among these two processes. So, by using this method, both processes can communicate with each other. In simply, there is a memory which is shared with all the processes, so all the processes can share their data within this shared memory. So, this is how this shared memory is working. And a message passing method, which there are two methods in the message passing, which indirect and direct. So, processes can communicate directly or indirectly by using a mailbox. So, these are the two methods which the processes communicate with each other, shared memory and message passing. Communication between processes using shared memory requires processes to share some variable, and it completely depends on how the programmer will implement it. One way of communication using shared memory can be imagined like this. Suppose process A and process B are executing simultaneously and they share some resources or use some information from another process. Process A generates information about certain computation or resources being used and keeps it as a record in shared memory. When process B needs to use the shared information, it will check in the record stored in the shared memory and take note of the information generated by process 1 and act accordingly. Processes can use shared memory for extracting information as a record from another process, as well as for delivering any specific information to other processes. So, here this is how the shared memory is working. Process A, which stores some information about its shared data here in shared memory, this memory location, and if the process B wants to use the data, it can be accessed it will access the data which is stored by process A in shared memory. This is how processes communicate with each other in shared memory. And one example for shared memory method is producer consumer problem. There are two processes, one is producer and another one is consumer. The producer produces some items and consumer consumes that item. The two processes share a common space or memory location known as a buffer. This is a shared memory location. A buffer, which is a temporary storage area, and where the item produced by the producer is stored and from which the consumer consumes the item if needed. So, a producer stores the producer produces some items in the buffer. From the buffer, the consumer consumes the item by the producer. Okay, this is how the producer consumer problem actually works. So, there is a producer, there is a consumer, both acts as a buffer. Producer produces item in buffer, consumer consumes item from the buffer. There are two versions of this problem. The first one is known as the unbounded buffer problem. Here unbounded means unlimited, in which the producer can keep on producing item and there is no limit on the size of the buffer. The second one is the bounded buffer problem, in which the producer can produce up to a certain number of items before it starts waiting for consumer to consume it. So, here we will discuss bounded buffer problem because it have a limited addition. Here in the unbounded buffer, there is no limitations for a producer to produce item because the buffer size is unlimited. So, the producer can produce any item, the producer can produce whatever he wants. So, the problem here is with a bounded buffer because there is a limited memory. There is a limited memory, so it will be memory will be full in certain amount of time. First, the producer and consumer will share some common memory. Then the producer will start producing items if the total produced item is equal to the size of the buffer. The producer will wait to get it consumed by the consumer. Similarly, the consumer will first check for the availability of the item. If no item is available, the consumer will wait for the producer to produce it. If there are items available, consumers will consume them. Here the producer, here the limited memory, for example, if I say we have like a stack, we have a, let's take a stack here. Let's take a stack which have 4 okay, which can store 4 elements here. The producer can produce items up to 4 elements. He cannot store more than 4 elements. So, he can produce up to 4 elements here, and producer producing like this A, B, C and D. Now, the buffer is full. So, the buffer is limited. The producer cannot produce any items further. Okay. Now, the consumer here can consume items from this buffer. Okay. This is how the bounded buffer problem is working. And the bounded buffer problem is also known as, this is the first question in this video, the bounded buffer problem is also known as producer consumer problem, reader writer problem, dining philosopher problem, and both reader writer problem and dining philosopher's problem. Just now we have discussed the bounded buffer problem is also known as producer consumer problem. And second method is message passing method. In this method, processes communicate with each other without using any kind of shared memory. If process 1 and process 2 wants to communicate with each other, they proceed as follows. They establish a communication link. If a link already exists, there is no need to establish it again. So, here both processes are going to establish a link, and now we have a link established between processes, and they are going to start exchanging messages using 2 basic primitives. One is send, another one is receive. One is send, another one is receive. And here this one is for direct method, send message to destination. This is direct method, direct method. This is a direct method. Here message to a particular process, send message to a particular process and receive message from the particular process. This is direct method. Or send message to mailbox, receive message from mailbox. This is indirect method. So, we have two primitives, one is send, another one is receive. Now, this is how the message passing modules are working. Process A, for example, process A wants to send a message to process B, which is receiving process. Process A sending a message to the message passing modules like this. Send here, send message to B, send a message to B, and then the process the receiving here the process ID here is which process we are going to send, which process we can say that this is P, process B, which is having ID. So, process A sending message to process B with the message, and process B will receive the message from the host A. This is how the direct method is work. As well as if we have a mailbox, then process A send a message to the mailbox and process B will receive the message from the mailbox. The message size can be of fixed size or of variable size. If it is of fixed size, it is easy for an operating system designer, but complicated for a programmer, and if it is of variable size, then it is easy for a programmer, but complicated for the operating system designer. A standard message can have two parts, header and body. The header part is used for storing message type, destination ID, number of process ID or name of the process, source ID, where from the source process ID, message length of the process, and control information. The control information contains information like what to do if runs out of buffer space, sequence number, and priority. Generally, a message is sent using first in first out style. And synchronous and asynchronous message passing, this is simple one. A process that is blocked is one that is waiting for some event such as resource becoming available or the completion of an input output operation. Inter-process communication is possible between the processes on same computer as well as on the processes running on different computer. That is a networked or distributed system. In both cases, the process may or may not be blocked while sending a message or attempting to receive a message. So, message passing may be blocking or non-blocking. Here, blocking means synchronous and unblocking means asynchronous. That is what we are going to see. Blocking is considered synchronous, and blocking send means sender will be blocked until the message is received by the receiver. Here, blocking is synchronous and blocking send means sender is blocked until the message is received by the receiver. Similarly, blocking receive is for the receiver side, has the receiver block until the message is available. We cannot retrieve an empty we cannot retrieve anything from the empty buffer. So, the message must be available there. Non-blocking is considered, next one is non-blocking is considered asynchronous, and non-blocking sent as the sender sends a message and continue. The sender has to wait, the sender is no need to wait for the receiver to receive the message. Similarly, non-blocking receive has the receiver receive a valid message or null. So, here blocking is synchronous, as non-blocking is asynchronous. There are basically three preferred combination: blocking send and blocking receive. Here sender is blocked and receiver is blocked, and non-block here blocking send means sender is blocked until receiver receives the message. Blocking receive means receiver is blocked until message is available. Non-blocking send means sender can send whatever the message he have, he don't have to wait for the receiver. And non-blocking receive, if the message is available, the receiver can receive the message. Non-blocking send and blocking receive, this is the mostly used method in inter-process communication. In direct message passing, the process which wants to communicate must explicitly name the recipient or the sender of the communication. Here, your example here, send message to process 1. So, we have to explicitly name the destination, process 1, process ID here. Similarly, receive message from process 2. Okay, we have to explicitly name the recipient or the sender. In this method of communication, the communication link gets established automatically, which can be either unidirectional or bidirectional. But one link can be used between one pair of the sender and receiver, and one pair of sender and receiver should not possess more than one pair of links. So, only two processes can be only two processes can communicate by using the direct message passing method. In indirect message passing, processes uses mailboxes, also referred to as port, for sending and receiving messages. Each mailbox has a unique ID, and processes can communicate only if they share a mailbox. Link established only if the process share a common mailbox, and a single link can be associated with many processes here, which means more than one process can communicate with each other. Each pair of processes can share several communication links, and these links may be unidirectional or bidirectional. Suppose two processes wants to communicate through indirect message passing. The required operations are to create a mailbox. First, we have to create a mailbox and use this mailbox for sending and receiving messages, and then destroy the mailbox. The standard primitives are send and receive. Here, send message to mailbox A and receive message from mailbox A. This is how the indirect message passing method is working. Okay, this is how the processes communicate with each other in cooperating processes. That's it for in this video. In the next video, we will see about process synchronization. Okay, thank you all.